All right, ladies and gentlemen, here we are with a Delta Math assignment called Write, Solve, and Graph One Variable Linear Inequalities. In number one, we are asked to select the value that makes, or values that make the inequality -3q less than or equal to 51 true. Then write an equivalent inequality in terms of q. This second sentence here just means solve the inequality. Okay, so what we're going to do is because the inequality is up here and we can't really work on it, we're going to come down here and rewrite it. Step one is to rewrite. Very often that is the first step in a math problem. And so let's rewrite -3q okay, and -3q what? Less than or equal to. So remember, less than or equal to and greater than or equal to, that's a closed-in dot. But do you notice this -3? We know we're going to end up having to flip this sign. Okay, and so I'm just commenting along the way. Now we write the 51. And here we go. So the only thing that's happening in this problem, this is a one-step problem, is that -3 is being multiplied by q. So if I want to unmultiply, I'll do the inverse operation of multiplication, which would be division. And that fraction bar means to divide. And what I do to the left, I must do to the right. So on both sides of the inequality, I have to divide by -3. And just remember that when you divide by a negative number, or you multiply by a negative number in an inequality situation, whatever the result is, you have to flip this sign. So this less than or equal to becomes a greater than or equal to. Well, the benefit of dividing by -3 is that I can cancel out these -3's on the left, isolating the q variable by itself. So my next line would be to write q and this time I'm going to flip the inequality. So now q is greater than or equal to, and now I've got to do 51 divided by -3. Now, if you're not sure if 51 is divisible by 3, you can compute something called the digital root. This is a really cool trick that, I didn't learn until after college. I wish somebody showed me this when I was in 7th or 8th grade. Okay, so what's the digital root? The digital root is just the sum of the two digits of this number, 5 plus 1. So the digital root of 51 equals 6, because 5 plus 1 is 6. And the question is 6 divisible by 3? Yes. Therefore, 51 is divisible by 3. Well, let's do this in our head. So 3 goes into 5 one time, with 2 as a remainder. Okay? So your first part of your quotient is a 1, because it went in one time. And remember, it's going to be negative. Okay? And now we're looking here at this 21. Well, 3 goes into 21 7 times, so it's -17. Ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen and women of the world, workers of the world, this is your solution, okay? Q is greater than or equal to -17. Let's graph it. Did it say to graph it? No. But do we stop and not do something just because the problem didn't explicitly demand that we do it? Of course not. Okay. We are on a journey of discovery. So this is negative infinity to positive infinity, and I've got -17 right here. Okay. And what I've got here is I've got a closed-in dot at -17, and I've got an arrow going to the right because it's Q is greater than or equal to. I've got this arrow going off here to the right. And we weren't given a number set, so we'll just assume it's all real numbers. I mean, all these answers are the integers, so who knows? But now let's start making checkboxes. Well, there's one checkbox at negative 17, because negative 17 is part of the solution set because it's a closed-in dot there. And all numbers that are less negative and all positive numbers will be part of the solution set. So, for example, negative 12, negative 7, negative 16, negative 14, and that's it. So all those answers, all those different solutions lie within this region, and that's why we draw the graph. And that brings us to the end of number 1. All right, so now we're moving on to number 2. Number 2. Here we go. Select the values that make the inequality x over negative 4 greater than negative 9 true. Then write an equivalent inequality in terms of x. Okay. Now, I should go back up here and put a box around this because this was part of the question. This was the equivalent inequality. In other words, that's just another way of saying solve the inequality. Okay, so let's do the same thing down here. Okay, so this one looks harder because of the fraction with the negative number, blah, blah, blah. But it's really easy. So we have x over negative 4. And then a greater than symbol. And then a negative 9. Well, I can tell you two things. I can tell you that the right side of the inequality is going to be positive, 36. And I can tell you that we're going to have to flip that sign. So it's going to end up being x is less than 36. But let's get there. Let's take the journey. So here's what we're going to do. We're going to multiply both sides by negative 4 over 1. Okay. And I'm going to go ahead and put the negative 9 over 1 so you understand like the fraction relationship. And here we go with our canceling. So when I have diagonally, when I'm multiplying two fractions, I can cancel diagonally. So this cancels and this cancels. And then I just have x over 1, aka x. And so I have x by itself on the left. And now because this time I multiplied by a negative, I'm still going to flip the sign. X is less than. And now I'm multiplying negative 9 by negative 4. Well, 9 times 4 is 36. A negative times a negative is a positive. So negative 9 times negative 4 is positive 36, ladies and gentlemen. Okay, so there's your equivalent inequality. So put that in a box. And let's go ahead and create our quick graph, like super quick graph. I'm just going to put 36 here. And then I'm going to put an open circle and an arrow going to the left. And that's how easy it is, folks. I mean, did that take more than 5 seconds? No, it didn't. Draw the graph, please. Okay, so now I'm looking for all numbers that are less than 36 and not 36. So do not put a checkbox right here. That's a trap. So let's see, 32, 33, 28, 35, and there you go. I believe I've got them all. Yeah, okay, All right, well, that is number 2, ladies and gentlemen. So we're now going to move on to number 3. Number 3, select the values that make the inequality z over negative a greater than or equal to 9 true. Then write the equivalent inequality in terms of z and draw the number line, even though that didn't say that there. We're going to do it. So again, I mean, this is almost an identical problem to the one above it. We have z. Okay, I won't write it in the cursive form. Just write z over 8. Over negative 8, rather, greater than or equal to 9. Okay. Well, what do I know about this problem? I know that it's going to be z is less than or equal to negative 72. Okay, but let's go through the motions. So first, I'm going to multiply both sides by negative 8 over 1. Okay, and then I'll make this on the right side. I'm going to go ahead and make 9 into a fraction, and we'll call that 9 over 1. And then I'm going to multiply the same thing on the right side, negative 8 over 1. Okay, so here's my diagonal cancellations. These negative 8s cancel out, leaving z all by itself. And that's what we wanted. We want to get the variable alone. Okay, hashtag forever alone. That's math. We want to get that variable isolated. Okay, so we have the z by itself. Okay, and remember, we multiplied by a negative, so we've got to flip this sign. Horizontal reflection of the sign. Now it's less than or equal to. And 9 times 8 is 72. So big brain, 9 times negative 8 is going to be negative 72. D-O-N-E. So let's put the red box of correctness. Big shout out to my man Jay. No last name given because of about 1,000 different laws that prevent me from saying his last name, but he knows who he is and he watches the channel. The red box of correctness is back, Jay. Thank you. That man could solve. I used to spend all of my paycheck buying puzzles, physical puzzles, and so that he could solve all of them. He was a genius. All right, so now number line. So we have like even level 10 puzzles. They said it's impossible. Nobody can do this. It takes 5 hours. He would solve it in like 20 minutes. Okay, so we have negative 72, and we're going to put a closed-in dot. And then we're going to point that dot to the left point the arrow to the left because z is less than, okay, or equal to. So negative 72 is one of the solutions. So we're going to put a big checkbox there. And now every number that is more negative, if that makes sense, like negative 80, negative 75, negative 88. And I believe that's it. Yeah, because all of the rest, well, hold on, I think here, negative 73. Okay, now I got them all. And the rest of these are less negative, if that makes any sense. Okay, so we are done with number 3. And now guess what we're going to do next? This is going to shock you. We're going to move on to number 4, okay? Wow. Select the values that make the inequality q over negative 2 less than or equal to negative 7 true, then write the equivalent inequality. Okay, in other words, solve the inequality, and then check all these boxes, okay? All right, here we go. We have q. Q is my favorite character in the James Bond series because Q is the quartermaster, and the quartermaster is the one that has all the cool tech. All right, so he's the one that has the, all the cool technology for James Bond. And I really do like the Q that they chose for the new series of James Bond movies. The young guy, and the old ones with Pierce Brosnan, the Daniel Craig James Bond movies I want to talk about, and the old ones with Pierce Brosnan and then all the others. It was always like an old man, like Alfred from Batman, which is what I think they were trying to crib from. But anyway, they did a good job. So, well, how are we going to get out of this mess? Well, we're going to multiply both sides by negative 2. So I already know we're going to flip the sign. So Q is going to be Q is going to be greater than or equal to positive 14. But how do we get there? Well, we multiply both sides by negative 2 over 1. And let's make negative 7 into a fraction so it doesn't feel lonely. And multiply by negative 2 over 1. And I hope you're starting to see, like, how am I able to solve this, like, instantaneously in my head? Because all we're really doing is just multiplying the right side by negative 2. So these cancel, leaving Q by itself. And I have Q, the quartermaster, Q, and remember I multiply by a negative, so I need to flip the sign, Q is greater than or equal to positive 14, because negative 7 times negative 2 is positive 14, ladies and gentlemen. And now we're going to put that in the red box of correctness. And we're going to draw the world's quickest graph. Let's count. Ready? 1 Mississippi, 2 Mississippi. Wait, that was too fast. 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi. 8 seconds. I mean, and I think I was going a little bit too fast. So 8 seconds max to draw that graph. And now let's take a look. So 14 is part of the solution. Check. And then all numbers greater than 14. Okay? So 10, no. 11, no. 12, no. 13, no. 15, yes. 16, yes. 17, yes. 18, yes. Okay? And that brings us to the conclusion of the wonderful story of number 4. And guess what? If you're following the sequence of events, we're going to increment to number 5. Okay, so here we are on number 5. Select the values that make the inequality 2h greater than or equal to 10 true. Then write an equivalent inequality in terms of h. In other words, solve it. And then check the boxes, blah, blah, blah. So first, let's solve this. This is the world's simplest inequality that I've ever seen in my entire life. We have 2h greater than or equal to 10. So there's no negatives here. All we have to do is divide both sides by 2. But just because you know h is greater than or equal to 5, if you don't show that work, you don't get any credit. So just show the work, divide both sides by 2. Okay? Show me how smart you are. And then let's show that cancellation. I want to know that you understand that you cancel when you have a number over itself. It's equal to 1. So that's what cancel shorthand for saying. H is greater than or equal to 5. Okay? So we're going to put that in a box. The red box of correctness, of course. And here comes the world's fastest graph. Here we go. 1, 2, 3, 4, 5. 5 seconds to graph the inequality h is greater than or equal to 5. So yes, we'll check 5. We'll check 6, 8, 10, and 15. And we'll leave negative 5, 0, 2, and 4 alone because they are less than 5. All right. Let's do an addition problem. Number 5 plus 1 equals number 6, ladies and gentlemen. Here we are. Solve the inequality and graph the solution on the line provided. Notice there's no, well, oh, there is a line provided. Oh, I was hoping there wasn't because we don't need it. Okay, let's, well, we'll do it anyway. Here we go. So finally, something new. How do we solve this inequality? Well, our goal is to get x by itself. Okay, so what I'll do to solve this inequality is I'll just get out my whiteout and I'll just erase the 2, the plus, the 10, and the negative sign. Oh, wait, that won't work. Okay, so let me put that away and actually do some mathematics. All right, so the first step is to, we're going to peel the onion from the outside in. Yes, eventually I have to divide by 2, okay? But first I have to get rid of this negative 10. So you have to do the inverse operation of subtraction because it's negative. So how do I unnegate something? Well, I'm going to plus 10. Okay, and we have to do that on both sides, plus 10, to keep everything in balance. And then, okay, these cancel out, and I've got 2x is less than or equal to, and be careful here, you have negative 18 plus 10. Think about a number line. You're at negative 18 on the number line. You're adding 10, so you're going 10 paces to the right. Okay, so where does that put us? Negative 8, I think. So 18, hold on a second. Yeah, negative 8. Okay, so negative 8. And now there's only one step left. 2 is multiplied by x, so we will do the inverse operation of multiplication, and that will be division. And we will divide both sides by the coefficient of x, which is the number 2. Okay, it's not a negative number or anything, so we don't have to flip the sign. And then we can cancel the 2's on the left, leaving the x by itself. In other words, we've isolated the variable. X is hashtag forever alone. And we have x is less than or equal to, big brain time, negative 8 divided by 2. Well, 8 divided by 2, if you cut 8 in half, you have 4. Negative 8 divided by 2 is negative 4. So there's my equivalent inequality. X is less than or equal to negative 4. And if I'm going to use the graph provided, I'm going to go down here and put a closed-in dot at negative 4. I'm going to make it cartoonishly large for the video. And then I'm going to put that arrow, because it's less than, I'm going to put that arrow going to the left, like this. Okay? And I believe that's all they asked for. Solve the inequality and graph the solution. Dunsies. All right. Okay, and I know what you're thinking. You're thinking, please don't ever say that again. Don't add z's to anything, sir. All right, so now let's look at number 7. Okay. What do we got going on here? Well, we have 3 multiplied by x, so I would love to divide 3x by 3, but I can't do that until I get rid of the negative 2, and so I've got to plus out the 2 by putting big brain plus 2, and then over here plus 2. Okay, and so the negative 2 plus 2, that's 0, so I just put a cancel through it, and then I've got 3x, 3x's less than or equal to, and then negative 17 plus 2 is negative 15. And you know you're on the right track because you know that 15 divided by 3 is 5. So negative 15 divided by 3 is going to be negative 5. So we know that 3 is currently being multiplied by x. So we're going to unmultiply it by dividing it. And here we are. We're going to divide both sides by 3. Cancel, cancel. And we have the equivalent inequality. X is less than or equal, well, I could do that better, less than or equal to negative 5. Okay, less than or equal to negative 5. So that's a solid dot on negative 5 with an arrow pointing to the left. Down to the number line, solid dot on negative 5. We have to, it's not written, it's in between negative 4 and negative 6. And then arrow pointing to the left, just like that. And we are done with number 7. Wait, I didn't put the red box of correctness around x is less than or equal to negative 5. How dare I? Okay, now that I've done that, I'm going to go on and I'm going to increment to number 8. Okay, looks like we finally have something that looks a little different. Negative 5x plus 8 greater than 3. And I am going to flip that sign because I have a variable coefficient that's negative, but first thing I'm going to do is subtract 8 from both sides because I want to get down to the metal here with that negative 5x. So I'm going to subtract 8 from both sides. And you start to notice, like, you can kind of feel, are you on the right track or not? I mean, 3 minus 8 is negative 5. So, you know, you can kind of like, well, okay, there's a negative 5x on the left side, and then on the right side, I've got a negative 5, so it's probably going to end up being 1. Okay, so now I have negative 5 over here. So here's our inequality at the present moment. Negative 5x greater than negative 5. So again, negative 5 is being multiplied by x. So to get rid of it, we will just divide both sides by the coefficient of the x variable, which in this case is negative 5. Dividing by negative 5 allows us to cancel on the left, but look at the right. Negative 5 over negative 5, cancel. Does that mean that's nothing left? X is less than nothing? No, because what's really happening is you have the same thing over itself, okay? Apple over apple equals 1. Negative 5 divided by negative 5 is 1. So this whole thing becomes 1 over 1, aka 1. So now I have x, flip that sign, less than 1. Okay? So don't let the simplicity of what's happening confuse you. And that's a real problem. So now what we're going to do is put an open circle on 1 right here. And less than will have us pointing to the left. Okay? Make sure you put that arrow. It goes on forever. All right, so we've done number 8. We're going to iterate our way to the next number in, what number set are we using? We started at 1, then we went to 2. We're using the natural numbers. So the next natural number after 8 is 9, so I better do number 9. All right, ladies and gentlemen, here we are with number 9. Ladies and gentlemen, we are going to start by looking here at negative 5x minus 3 less than or equal to 32. Because it's negative 5x, I already know I'm going to flip that sign. So at the end of this problem, it'll be greater than or equal. X is going to be greater than or equal to negative 7, I think. But that was, I just eyeballed that. I don't know. So first thing we're going to do is plus 3 on both sides. Plus 3 on both sides, okay? And that allows me to cancel out these 3's. Those are annoying. And we're going to bring down the negative 5x here. And then we're going to keep the less than or equal to symbol because I have not yet multiplied or divided by a negative number. And 32 plus 3 is 35. But now I'm going to divide, because remember, negative 5 is being multiplied by x. So I'm going to divide both sides by the coefficient of the variable. What? I'm going to divide both sides by the number sitting to the left of the variable with its sign. The number sitting to the left of the variable, and the variable is x, is negative 5. So I'm going to divide both sides by negative 5. Okay, and I was right. It's going to be negative 7. So the negative 5's cancel. Bye-bye. And we have x. Flip the sign because we divided by a negative is greater than or equal to negative 7. Okay. All right, so red box of correctness goes around that. Yeah, I actually like, encourage you to try to solve it in your head, okay, and then do the work. And if your head work matches what you get when you do the calculations, guess what? You're probably right. Okay, so now we're going to put a closed-in circle on negative 7, which would be between negative 6 and negative 8. And I put a closed-in circle here. And finally, I get to do a greater than. So I'm going to go off to the right forever. Okay? There we go. Forever. Forever and ever and ever. And finally, ladies and gentlemen, brothers and sisters, we have made it to the final problem. This is like the boss fight at the end of a level. Here we go. Number 10, solve the inequality and graph the solution. And then we've got a bunch of big numbers. Oh boy. So is this going to be hard? No, it's going to be super easy because when I add 69 to both sides, I'm basically going to subtract 69 from 75 and I'm going to end up with negative 6. Okay, so anyway, just watch. Okay, so I'm going to put plus 69. Okay. On the left and on the right, plus 69. And remember, what's really happening, because the greater magnitude number is the negative 75, we're really subtracting 69 from 75. So just ask yourself, how many numbers are there between 75 and 69? Just count, there are 6 of them. But so the answer is negative 6 because it's the bigger number negative. Okay, so these are gone, and we now have negative 6x. So this hard problem just became ridiculously easy, is less than negative 6. Okay, now it doesn't take a supercomputer or a genius to figure out what to do next. Negative 6 is being multiplied by x, so we're going to divide by the coefficient of the x variable, which is negative 6, and then we're going to divide negative 6 by negative 6. We've already had a problem like this, so this should not be a shock. When I cancel, and I cancel, I leave behind 1's over here, okay? And so x, now flip the sign, is greater than 1, okay? So what am I going to do? Well, I'm going to come down here to my graph. I'm going to put a circle around 1. And then it's greater than 1, right? So I'm going to go put an arrow off to the right into forever. Thank you so much for watching. That was number 10. I really appreciate it. Make sure to like, subscribe, hit the notification bell so you're always alerted to get when I release new videos. Thank you.